we're going to be converting between rectangular and polar. Now, sometimes kids will say, wait, what do you mean rectangular? Well, good news. Rectangular is actually like the way that math used to be, X and Y. X and Y are rectangular coordinates because you move horizontally or vertically. So we use the phrase rectangular. Polar, well, I hope you realize that's what we are talking about. That's when we use r and theta. So it might occur to you at some point in the next 40 minutes, you're like, wait a minute, which way did we go? Because we're going to be going like in both directions. Sometimes we're going to go to r and theta. Sometimes we're going to go to x and y. We're going to be like converting between the two. Now, when you convert, that implies that you're coming up with an equal answer. So obviously the numbers might be different, but we're still going to come up with numbers that would be in the same place. And that's exactly kind of where I want to start. I want to start in a place. And that place is on the back of your paper. We're actually going to use the back of the paper to start out because that's where we're going to do some like discovering. Okay, I call it scribble and scratch, but basically we're going to discover some things. Have a calculator handy. It just helps if you have it handy now. You're going to use it in a moment anyway. If you have to borrow one, make sure you borrow it. Okay, and if you ever need something, if you're like, Mr. Miller, where are you at on the paper, just ask. But I'm on the back of the paper on the left side, and I'm going to give you a point. It's actually the point 6, -6. And right off the bat here, let's just make sure that you understand that that's a good old rectangular point. Like 6 for the x and -6 for the y. Where is that? Where is 6, -6? Okay. Well, we should know. I was about ready to put it in the wrong place myself, but of course, if I move 6 units in the x, but -6 units in the y, well, I'm always going to end up in this position, in this place. Now, for the next couple minutes, what we want to do is we want to try to describe that place using r and theta. We want to try to figure out how we can get there with r and theta. So let's do some stuff that I don't think is going to surprise you 100% because you've actually seen it before. When you start drawing lines, you start to see r. When you start drawing lines, you start to see theta. Now, what I've done there is something that, well, we haven't necessarily done just yesterday, but we've definitely done quite a bit this year. That is making a right triangle as part of numbers, as part of points. And so here's the cool thing. This right triangle has exactly what we need. It has a radius. It's actually the hypotenuse, but it has a radius, and it has an angle. And that's basically what we want to try to find. Okay, so how can you find it? Well, let's label this triangle a little more. How you would have put like the dimensions on those legs. That makes good sense. Hopefully it also kind of causes you to start to think about how you can solve for r and theta. How about r? It's not supposed to be a trick question. It might even seem like it's kind of basic. How do you find r? Again, maybe it's even a little too basic because we should know that it's the Pythagorean Theorem. So let's do a little 6 squared plus -6 squared. Let's do a little bit of r squared equals 6 squared plus -6 squared. Again, as you do this, even though it's kind of easy, make sure you realize that that's going to give us the distance out to that point. Okay. Of course, be careful. Mind your manners. Make sure that when you square -6 that you still get positive 36. So we really end up with 36 plus 36, which of course is 72. But we really end up with the square root of 72. Now, the square root of 72 can take on some different forms, right? First of all, you could change it to a decimal. That's fine. If you put it in your calculator, that's probably what you got, about 849, right? Don't forget, though, as you guys keep growing and maturing in mathematics, that sometimes when you have a square root, that it's appropriate to simplify it. I say sometimes because it kind of just depends on maybe what the instructor or the teacher expects. But there's a perfect number inside of 72. There's a perfect number inside of 72. It's the number 36, and you can pull that out. And you've done this before. You pull out 36, you get a 6, and it leaves behind a root 2. So I just want you to see the answer as 6 root 2, because who knows, maybe that will be helpful someday. But you're allowed to get the decimal, and we're on our way to finding r and theta. Let's talk about theta. It's an angle. Okay, it's been the new idea this year. I know we kind of go from concept to concept, and sometimes you're just trying to hang on. But angles is really what started the conversation of trigonometry many months ago. And remember that this angle would tell us that side -6 is the opposite side. This angle would tell us that this side 6 is the adjacent side. Now, I just said two words there, opposite and adjacent, that fit into a really nice trig function. It's called tangent. Now, the tangent of theta is always equal to opposite over adjacent. The tangent of theta is going to equal -1. Of course, if you want to find theta, you should feel like your calculator can help you to do the inverse. So actually, on your calculator, you do the inverse of -6 over 6. Or if you like, just do the inverse of -1. What do you think? Does it kind of look like an angle? Make sure your calculator's in degrees. If your calculator's in radians, it might be spitting out some garbage, but the inverse of -6 over 6 should spit out -45. Nice little angle. We just converted to a polar point. Okay? I don't know if it has a huge wow factor to it, but we just converted. We now have the ability to write a point. Now, in all honesty, you need to write it as a point. Like you need to put a comma between 849 and -45. Because when you do that, you're actually making it an ordered pair. So we can do this. We can change from rectangular to polar. You want to try one? Maybe kind of see if it works next time? Just give you a chance to slow down and think about what I just did. Maybe think about a little bit on your own. I'm still on the back of the paper, -3, 4. Can you change -3, 4? Can you change it to r and theta? Make a sketch, especially if you're kind of wondering where to start. I would make a sketch and see if you can get a little triangle to pop out of that sketch. Okay, now be careful. Although I didn't walk around and maybe look, I know that it's not uncommon for students to accidentally graph this in the wrong place. It happens to the best of us, so just make sure that your point is actually in that quadrant. Okay, if you're making a sketch, just be careful. How's it going for you? Do your answers make sense? A little Pythagorean theorem actually should have produced a nice round 25. Of course, if r squared equals 25, then you actually end up with a even nicer radius, just 5. Okay, so nothing too fancy there. How about the whole angle thing? Again, it's one of the main ideas from this year. It's going to be opposite over adjacent again. I actually want you to realize that tangent always gets the job done because it's always going to be an opposite and an adjacent. If you do the inverse tangent, you have to do the inverse on your calculator. If you do the inverse tangent, it should have spit out negative 53 and a little bit of change, right? Negative 53 and a little decimal if you'd like. And if you take your two numbers and you write them as an ordered pair, well, you would be wrong. You would be wrong. It's not too often I tell kids that you're wrong, but it's actually not right. Now listen, this is important. I'm glad you're here today, but it's important that you realize why this is wrong, not just because I'm saying so. Where is negative 53 and a 5? How do you graph that? We learned how to do that some time ago, and it got broken up by snow and by Christmas, but think about it with me. Negative 53, that would be like rotating down here, okay? And if I go 5 units out, that's going to be right there. What's going on here? Okay, well, as I said, it's not right, but what's going on here is it just needs a simple fix. Okay, and the fix isn't that we have to use a different tangent, or the fix isn't that these numbers are upside down. The fix just has to do with noticing something about the connection between my 2 points. Or maybe I should say sort of the position of my 2 points. I don't know if there's a reason you would know this, but can you speculate on how far apart these 2 points are? What I'm talking about is how many degrees separate these 2 points. How many degrees is correct? So how can we take negative 53 and go 180 degrees to over where we want to be? Yeah, good. It's actually pretty easy. Just add 180. So if negative 53 is still on your calculator screen, good. Just add 180 to it, and you will have the right answer. So we can just add 180. Comes out to 126. Now think about 126. And again, this is part of the lesson where you're here today, so think with me. If you think about 126, well, that's actually good, because 126, I got a lot of arrows on the board here. Let me get rid of some of this stuff. 126 is just starting at 0 and rotating, rotating 126 degrees. Yeah, that makes sense. That looks good. So it's fixed. Now, maybe you're wondering, why did we have to fix this one? Well, it has to do with the x value. You see, the x value from the original given was -3. And if the x value is negative, you're going to have to add 180. You're going to have to fix it. Let's use the front of the paper to make some conclusions. I know we started on the back, but it's the front where we're going to kind of put the final answers. Here's the scoop. If you are converting to polar, the Pythagorean theorem is always going to get the job done. So you'll notice that I wrote it down in its square root form, but please understand that that's the Pythagorean theorem. R equals the square root of x squared plus y squared. So that'll always work. It's the theta that you got to be a little careful about. You see, the theta is going to involve an inverse tangent. Again, you'll notice I wrote it down as an inverse, but it's going to involve a tangent, or I should say, there's the possibility that I might have to fix it and add 180. Make sure you realize that it's all about x, because if x is negative, if x is less than 0, if x is negative, then I have to add 180. But if x is positive, we're good. We don't need to kind of like worry about changing the answer. Now look, I'll be honest, I don't like to just give you formulas. I like you to understand them. And even though I did give them to you, I hope you understand that they really came from this basic theory of a right triangle. And a lot of students like to go back to the theory. Great, go back to the theory because it'll work every time. But every time you go back to the theory, it's going to take you to these formulas. Okay, so again, it's kind of the same thing. It's just up to you how you decide to approach it. On the front of your paper, why don't you see if everything works for -3, -5. Basically, I'm giving you a problem to kind of get correct. Do you want to use my formulas? Do you want to make a little sketch? Why don't you just give it one last try and see if everything's working? Again, use the formulas, make a sketch. I kind of encourage you to do both. You can move up, you can move over, anywhere. Do the numbers that you're getting, do they actually take you to the same place? That's the goal. Do the numbers that you're getting, do they take you to the same place? Okay, if you did a little Pythagorean theorem, and if you wrote it the way I kind of have it up here, you end up right away with the square root of 34. If you turn that into a decimal, 583. Just to be clear, you can leave the answer square root of 34. You can change it to 583. It's not a big deal. If you plugged into my formula, you would still be doing the inverse tangent. It's always y over x. So that is important. Make sure it's -5 over -3. But that's technically the opposite over the adjacent. Okay? Now, you could notice right away that the x value is negative. I would say that you probably do want to notice that, because that means that the angle that I get here, which comes out to 59, needs to be fixed. So you can fix it right away. You can add 180, and that way you're never coming up with the wrong angle. Okay, so I add 180 because the x value is negative, and 239 is more like it. Make sure you take 5 seconds and write it as an ordered pair. Yes, I want to see you write it as a point because, well, that's technically what we're trying to find. Okay, the only other thing that you could do if you had some time or you just were curious is you could graph it. And if you graph -3, -5, I'm talking about like a good old x and y, I hope you end up in this quadrant. If you rotate 293, you would come up with the same position. So that's good. That means that we're right. Okay? How do you check 5? Well, it's kind of hard to do. You go out 5 circles, 1, 2, 3, 4, 5, and then 0.83. I didn't draw it to scale, but it's going to take you to the same place. You're checking at the angle that the angle matches. Okay. Polar to rectangular. Rectangular to polar. We're now going to switch it up. Okay. We're going to switch it up, so try not to have your brain get sort of mixed up, but we're going to flip it over to the back of the paper. Let's discover something. Let's do a little scribble and scratch. Please understand that we're now going the opposite direction. Now, if we're going the opposite direction, that means I need to give you an r and a theta. I need to give you an r and a theta. This is going to be a little theoretical. It might excite some of you. I hope that everyone, though, that you understand it, but this is going to be a little theoretical because, like, I'm not actually giving you numbers here. We're kind of like pretending that we just have an r and a theta. But let's check it out. If you have an r and a theta, well, again, I don't think you're going to be super surprised as to what you can do. First of all, if you have a theta, which we often think of it first, if you have a theta, then you would be able to sketch some angle. And like I said, it's just theoretical, so don't worry about the exact sketch. It's just some angle. Now, if you have an r value, you would also know this distance. Okay, so I would know the theta and the r. But is it a big surprise to you to see me go like this and like this? In fact, you realize that that is super helpful because that is x and y. The sides of the triangle are x and y. Now, some students might look at what I sketched there and say, no, that's just kind of like the same thing you did on the other side. Well, the reason that it's different is because now I'm going to start with r and theta, and I'm going to try to connect them to x and y. How do you connect r, theta, and x? How do you connect them? That's a pretty deep question. So if you're like, I don't get it, what do you mean connect them? Am I supposed to draw a line between them? I'm not talking about like that. I'm talking about some type of mathematics that connects these 3 variables. What do you think? Kind of a deep question. Good. Okay, it's true what you're saying, that would be like a side angle side. I'm trying to think of how we can kind of run with that, Maddie. It's true. I guess to sort of put it nicely, it won't be helpful this time, but it is true. You're right. They would connect that way. And maybe I should have said to also take advantage of the right triangle. Now, it's all right if you want to pass, but if we use the right angle, Pass. You're warm. You're sort of in the right, you sort of have the right drum beat. You know, the boom, 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 boom. It wouldn't be sine, though. Good. This is adjacent. This is hypotenuse. Now, it's kind of deep, so just relax if you're like, you lost me a little bit here, Miss Naylor. But the truth is that cosine of theta, or I should say cosine, connects these three variables because the cosine of theta is adjacent over hypotenuse. You've learned that before. It just kind of popped back up here. Now, if you're saying, why? Why did we suddenly say that cosine is x over r? Well, check this out. You can solve this for x. You can just swing r over here. You can solve it for x and write it as r cosine of theta. X equals r cosine of theta. Whether you realize it or not, that's what I seek. I seek x. And if you seek, you shall find r cosine of theta. Try it again. Try what again? Try to relate y, r, and theta. Y, r, and theta. How do you relate y, r, and theta? And use the right angle. This time it's sine of theta. Right. Now, if it's all right, I'm going to back up to, before that, I'm going to back up to the sine of theta is opposite, which is y, over hypotenuse, which is r. But yes, Giuseppe, that means r sine of theta equals y. Now look, on one level, I don't want you to worry if you're like, you kind of lost me a little bit. But I do want to show you this because it's true. It's true that these two formulas are going to help you get x and y. But that's exactly what they end up being. They end up being formulas. Okay, now, do you want to kind of test them out? Do you want to see, what they really do for you? Let's see if we can kind of squeeze this in here. How do I have it written on your paper? It says to change. I'm still in the back of your paper. So let's change -3, comma 120. Let's change that to rectangular. And we'll kind of do it together because I want you to realize that this actually is a little easier than what we just got done doing on the other side. The reason it's a little easier is because we got ourselves a pretty handy-dandy formula. It says that x equals r, well, r is -3, cosine of theta, and theta is 120. Well, that ends up being just a little calculator computation. I encourage you to check it out, just make sure that it's working. But you're just going to take -3 times the cosine of theta, or times the cosine of 120. Okay, it should come out to 1.5. Again, check it out. There's nothing more than just plugging it in and realizing that if you're going to do the y value, we got ourselves a handy-dandy formula. It's just r sine of theta. It's interesting. It's the same r value, -3. This time it's sine, but it's the same theta, 120. So the only difference is you're going to pop out that sine function on your calculator. Is this all there is to it? Do we have to be concerned about any funny business? If you round that, I think it rounds carefully to -2.6. But yeah, it's pretty close to that. Again, is there anything else? Is it right? what I'm insinuating is that we should always be mindful of a sketch. Now, if you make a sketch, you can rotate 120. Okay, rotate 120. It's kind of like we've always done. It'd be somewhere around here. But, but it's an opposite of 3. Now remember, when we learned this some time ago, the opposite of 3 actually takes you back over to this side. So then I can go out 3 radii. Now that big yellow point right there is really where negative 3, 120 would be. Well, thank goodness, because that's also where 1.5, and negative 2.6 would be. So we got a winner. We got a winner. I really should write this as a point. 1.5 comma negative 2.6. If you don't want to recopy it, then just write it that way in the first place. But yeah, I should write it as a point because that is the same place. Go back to the front of your paper. At least I encourage you to, because we got ourselves 2 little formulas. We got ourselves 2 little formulas, x equals r cosine and y equals r sine. Are you sure? Is everything kind of like how you expect it to be? Well, try one. Try one on the front of your paper. 6 negative 100. Again, I'm on the front of the paper, on the right side at the top. And see if you can change that to rectangular. 6 negative 100. Just trust those formulas, but then double check. Do your numbers actually get you to the same place? They should. Oh, that way you'll have space there tomorrow. Looks good. Looks good, kids. I would expect that you're getting this right. We'll keep working on it, but you're at a good spot right now. I like that some of you are also. That's always a good idea. A little 6 cosine negative 100. A little 6 sine of negative 100. Basically, I was just making sure you realize that you don't need to worry about fixing anything. It's going to be right every time. Negative 104, negative 591. Okay, those 2 numbers, when written as an ordered pair, will take you to the same place. And just to get that exercise one more time, to rotate to negative 100 is actually going to rotate down here. Now, that's a little tricky, but that's negative 100. You have to rotate backwards. And if I go out 6 circles, 1, 2, 3, 4, 5, 6, I'm going to be somewhere around here. And that somewhere looks an awful lot like negative 1, negative 5.9. Okay, which is why this is correct. Now, today we converted points. We ended up with some formulas. Tomorrow we're going to take this to the next level and we're going to convert equations. Okay, it is going to be a little more involved and I'll have to go a little bit faster, but the good news is that it relates back to today. So we want to get you a good firm foundation today. Practice it with the homework like you normally would. There's a homework helper. Okay, but I hope you come back tomorrow for sort of round 2 where we'll do this with equations.